Hello, everyone, and welcome to another Cloud Tooltime webinar. Joining us today, we have Jonas Helming to discuss strategies for migrating Eclipse-based applications to the web. Dr. Jonas Helming is a general manager of Eclipse Source, as well as a consultant, trainer, and software engineer. His focus is on web-based development tools, IDEs, modeling, and the Eclipse ecosystem. Dr. Helming is the author of a book and numerous articles about the Eclipse ecosystem. He is an active member in the Eclipse community, currently leading 2 projects, and is involved in many others. If you have any questions for Jonas as we move through today's presentation, feel free to ask it in the chat or using the tab at the bottom. Without any further delay, Jonas, over to you.
Thank you very much for the introduction. Hello, everyone. Thanks for joining this talk today. I'm already introduced well. Thank you very much for that. And today I want to talk about strategies for migrating Eclipse-based application to the web. And now that you're here, I assume you're in the process of evaluating that. You maybe have a existing Eclipse-based application and you want to migrate that somehow to the web, or you're thinking about that and might want to do that in the future. Now, we at Eclipse Source, we are actually supporting our customers in building tools, IDEs, and domain-specific tools. And one of our core business at the moment is actually supporting migrating projects because a lot of tools are currently migrated to the web and the cloud. And when we observe those projects and our clients, there are a couple of recurring questions, especially in the beginning of such a migration, like strategic questions, organizational questions, technical questions. So the motivation of my talk today is essentially try to answer as many of those initial questions as I can for you to hopefully provide you with a kickstart for your own migration project, maybe guide you in the right direction, maybe think you make you think about some questions or some issues you might have in your migration project. Of course, I cannot answer all the questions because it gets project specific pretty soon if you think about a migration project. So I can only stay on a generic level because I cannot know about your specific project. However, we will definitely have enough time to cover many questions at the end of the session. So if you have any specific question, feel free to post it in the chat, and I try to address as many as I can. Right, so this is what we talk about today, the process. So you have something based on Eclipse Desktop, may that be a tool or an RCP application or an IDE or anything, or even a plugin, and you want to migrate that to the web/cloud. Now, the first question is actually that maybe a little bit of a background question is, what does that actually mean, a web-based tool or a cloud-based tool? Because those terms are usually used together or interchangeably, but what does that actually mean? So let's answer this question. Disclaimer, this is not an official definition that is somewhere on Wikipedia, but this is how people usually use those two terms. And we, for example, at Eclipse Source, we use it this way. Now, a web-based tool is a tool that uses web technologies, as the name implies, especially in the UI, such as HTML, CSS, TypeScript, and JavaScript. So essentially, at least the UI of a web-based tool is somehow implemented using these technologies. And then consequently, it uses a browser to render this UI. A browser can also mean Electron, for example. So it doesn't necessarily have to be something like Chrome or Firefox. More precise would be the browser engine that you actually need to render a web-based UI. What's usually also in a web-based tool is an architecture pattern that we can observe, and that's a split between UI part of the tool and a backend part of the tool. The UI part basically only takes care about rendering, while the backend part or server is responsible for the business logic of the tool. Even when we talk about a desktop tool, and we will see in a second that there are web-based desktop tools, we usually have this split. So it's a pretty clean architecture that is very similar to a standard web application with the client and the server part. So compared to many desktop tools where the business logic is not as well encapsulated, here we have a clear cut between UI and backend. Now, a cloud-based tool, in contrast, is essentially a web-based tool, but the backend is then deployed remotely somewhere in the cloud, and you access the UI via a browser. You can even access a cloud-based tool with a desktop application so that the desktop UI basically connects to a remote backend. And that's a little bit of a special case. But from my point of view, cloud-based tool, what this really means is that the backend is running in some cloud container. And those two terms are very intertwined because cloud-based tools are usually web-based. Makes sense because you want to access the UI somehow, and the most convenient way to do that is a browser. And web-based tools are usually prepared for the cloud, and that's due to the web-based UI and the split between client and server. Sounds all very complex, but for example, if we look at VS Code or Theia for an example, they can both be deployed as desktop applications and as cloud applications. And the architecture, the underlying architecture is essentially the same. So, going web-based often has the motivation to go cloud-based at least later. So let's look at this typical architecture of a web and also cloud-based tool. So as mentioned, we have the split between a front end and a back end. Front end runs in a browser engine, and back end very often runs on Node.js. That's typically the most common way to do it, but very often also integrates other technologies, for example, Java, C, or any language that you actually need to provide the business logic of your tool. A typical example for other languages that you integrate in a tool are language servers. So for example, if you want to provide Java support in your web-based tool, this Java support as a Java language server is typically written in Java, and you can then integrate that with your Node.js backend. And now there are two, as mentioned before, there are two typical deployment scenarios for this. If you deploy the client somewhere locally in a browser, for example, and the server somewhere in the cloud, you have the cloud deployment. And if you bundle both together, for example, with Electron, you can even have a desktop tool that has this architecture inside, uses a browser engine to render the UI, but it's still a desktop application at the end. Now, one question might arise when you start a migration project, like, does it make sense to go for a web-based desktop application, or do you directly head towards the cloud and an online tool? Now, let's look at the pros and cons. Because many people think, okay, we directly have to go to the cloud, but in practice, quite a few projects all go to the desktop instead of directly going to the cloud. Now, what are the advantages of a desktop-based tool? First one is users get what they used to. Depending on your user base, they might still want to have a desktop tool that they can install on the machine that has perfect integration with some hardware, with keyboard and so on. So some users might not want a browser-based application. You still have modern rendering. So as you use HTML and JavaScript for the UI, you can do everything that you can do in the browser in terms of the UI, but still all desktop features, like you have access to the local hardware and so on. However, you have this local setup. So the tool has to be installed. And if the tool has prerequisites, I don't know, a Java tool needs Maven installed on the system, you still have all this local setup that you have with a desktop-based tool. Now, for online or cloud-based tool, you don't have this set up for the user because you can automate that. So ideally, the user just has to click a link, which is very convenient for onboarding new users because you can handle everything in the cloud and set up a default working environment. Now, the advantage is there is potential for new business models. So depending on what you do, you might want to, or you might provide your tool as a service. So people don't need any local infrastructure anymore, but they can just use your cloud to code. Something like, for example, that GitHub Code Spaces does. And other use cases, like, for example, if you're a hardware vendor, you could provide access to a data center where there are a lot of devices connected to some central service, and then developers can actually deploy their code to devices in this data center rather than having the devices at their work desk, stuff like that. Depending on your domain, there might be other interesting business models if you move your tooling to the cloud. Maybe to mention even another example, if you're a vendor of machines that can be programmed, you could even think about deploying your tool directly on the machine. It's not strictly speaking a cloud deployment then, But then, for example, developers who want to program on that machine or robots or whatever, they can just access the tooling and the device that they program at the same time, just using the browser. What is the downside of going online? So you have to expect a significant effort to set up the infrastructure and to maintain the infrastructure. And by you, I mean the provider of the tool. This must not be underestimated. So, I mean, the advantage is you take the setup issue away from the user, but that means you have to solve it in a central way, which has to be very reliable. You have to do some load balancing. You basically you're moving the development environment from a local machine to your cloud. And that means you have to deal with all the issues that developers have with their infrastructure. And you have to solve it in a central way rather than developers solve it on their own, which from an efficiency point of view definitely makes sense, but it is not at zero cost. So depending on, again, your business model or your tool, expect some significant effort for hosting cloud-based tools. Another thing that you should not forget is providing an online tool might conflict with some security or IP governance rules for some use cases. So some of your customers might not agree to commit their code, for example, or their development environments to your infrastructure. And if that's true, you might even need to provide a cloud-based version of your tool that you can still install on a private cloud, let's say, which obviously also increases the effort of providing a cloud-based solution, because providing it, like hosting it yourself and developing it yourself is one step, but then if you want to transform this into something that an arbitrary client can install on their own cloud, that's even adding even more effort to the game. Now, what is the consequence of this? The good news is, independently of what you decide for, in terms of implementing the tool, you can single source most of the tool features in both variants. That means if you implement a concrete feature in your tool, you most of the time don't have to worry whether it will be deployed on the desktop or on the cloud, because both variants share most of the code. There are some exceptions, for example, when interacting with upload, download versus save as, something like this. Or, for example, when interacting with external hardware. So in Electron, you can actually more easily get access to the host machine, but there are also ways to do that in a browser with, for example, WebUSB. However, most of the, like, for example, the UI and most of the business logic will actually be the same, whether you deploy it as a desktop or an online tool. As a consequence, many vendors, not all of them, but many follow a dual strategy, going for a web-based tool on the desktop first, because that's the smallest step. You don't have to worry about the hosting from day one. But the web-based tool is actually prepared to be moved to the cloud later. And then in parallel to finishing the web-based tool, you can actually start to work on an offering to host this online in the cloud. And you can even run both at the same time if that adds value. So you can even provide both solutions if that fits your domain. Now, let's talk about the underlying tool platform when you decided whether you want to go for desktop or a cloud-based solution. And there are other options, definitely, but I want to focus on Eclipse Theia, obviously, and VS Code, which I would claim are the most common choices if you want to build a tool. Now, both basically have some extension mechanism, and both basically allow you to customize or to be customized to some specific requirements. Be aware, this will be a short comparison. I could easily talk 45 minutes only about comparing Theia with VS Code. So if you want more details, please feel free to ask me questions in the chat. And also there's an article linked here on the slide that you can read for more details. So in a nutshell, the comparison, let's start with VS Code. Now, VS Code is definitely, or maybe not definitely, but many claim it's the most popular code editor at the moment. So many of your users will know or already use VS Code. In contrast, Theia is very similar to VS Code from a usability and UI point of view. So many people would not, if you provide a vanilla tool based on Theia, many people will not know or would not notice the difference to VS Code actually. Now, VS Code is an extensible code editor, and it's extensible via so-called VS Code extensions. And that's really the core concept of VS Code. It is a tool that is provided, a code editor, and you can extend it with extensions. Theia also supports these VS Code extensions. So whatever you can use, whatever features you can use in VS Code, you can also use in Theia. And now we come to the main difference between VS Code and Theia. So VS Code is an extensible tool. It is not really meant as a platform for you to build a custom tool on. If you want to go down that route and if you want to use VS Code for that use case, it might be necessary to fork the underlying code and basically compile your own version of VS Code. And that's due to the fact that VS Code defines certain ways it can be extended, but you cannot extend it beyond that. And that's actually that's an explicit design decision in VS Code that it allows the extensions to do certain things, but not more. From the viewpoint of an extensible tool, that actually makes sense because it's hard to harm the stability of VS Code from within an extension, which is good for a tool because whatever you download in your VS Code instance, it will probably not break the code editor. However, like limiting this API conceptually as a consequence means that you cannot change certain things in VS Code from a VS Code extension. Now, Theia is explicitly, and that's the main difference, is explicitly meant as a platform. So Theia, or Eclipse Theia, is actually not a tool. It is a platform to build tools. And consequently, it's very flexible and adaptable. So you can, without forking, customize almost everything in Theia to build custom tool distributions. They can be completely white labeled, completely custom branding. You can support a very different feature set than the default. For example, you can add a toolbar like the Arduino IDE did, change the UI, change colors, remove menu items, add very custom UI that is not even centered around code and so on. So this is really the main purpose of Theia, to support implementing custom tools and IDs. From an organization or governance point of view, VS Code is open source, but it's mainly controlled by one vendor. And some of the components in VS Code have restrictive licenses. Like, for example, the live share feature is not open source. The marketplace of VS Code is not open to other tools and so on, which again makes sense for a extensible tool. And it's just, or from my point of view, it's basically due to the fact that it's not a use case for VS Code to be a platform for your tool. It's a tool that you can extend, not a platform. Now, Theia as a platform has a vendor-neutral governance hosted at the Eclipse Foundation, and consequently a growing ecosystem of supporting vendors and adopters. And you really have an ecosystem there. Like, and VS Code has a huge ecosystem, for example, of extension providers. And if you look at the marketplace, it's actually amazing how many features you get there, and that's super great. But there's not really a dedicated ecosystem for people adopting VS Code as a platform, again, because it's not a foreseen use case. While Theia is a place where people that adopt the tool basically can meet, can contribute to the project, and can coordinate their efforts. Now, again, what is the consequence? I mean, at the end, you have to decide between the two. It's worth noting that as Theia supports VS Code extensions, if you're not 100% sure which way you should go, everything that you implement as a VS Code extension can be used on both. And some vendors actually follow a dual strategy. They provide some features as a VS Code extension, which can then be installed by all the VS Code users, but you can also use them in Theia. And in addition, they provide then a full custom tool that is highly optimized for the particular use case based on Theia, because that's where you have the ability to really customize the tool based on your requirements or based on your UX that you want to fulfill. All right. So after thinking about those basic questions, like whether you want to go for a desktop-based tool or web-based tool, whether it's Theia or VS Code, what's the next step when you look at your own custom tool? Like, how do you prepare a migration? So I strongly recommend to start with some conceptual assessment of your Eclipse tool or plugin, and not directly dive into the technology decisions. The reason for that is the migration of Eclipse-based tool to the web is not something that happens every day. That's more a project that you will probably need to do every 10 or maybe even every 20 years. So it's a major endeavor. It will involve some very significant effort. So you should plan it well. And that, from my point of view, starts with like a conceptual assessment or some conceptual thoughts before you think about the technical realization. And if you do this right, you can very likely save a lot of money. So what does that mean? I strongly recommend to look at your current workflows in your tool. Like, I don't know, whatever you do, textual, language support, graphical modeling, analysis of some data, whatever you do, and redesign your workflows. First of all, maybe you have some general requirements or general overhaul of your usability concept that you wanted to do since a long time. But even more important, think about your workflows, how they fit into a web-based UI and potentially a cloud-based world. Like, for example, if your existing tools shows the status of a build server inside of the IDE, if you think about that in the web, does that really make sense? Because the user or the developer could just open another browser tab and look at the build server directly without like having this integration. And there are many of those examples where the world has turned a bit, and the existing assumptions of your workflow and also your features in your tool might not be valid or might not be the best choice anymore. That also includes removing unnecessary features. So really think about the value of all the features in your existing tool before you plan their migration. It's actually statistically proven that in many tools, only 60-70% of the features are actually used, and many features are never used. And before you actually spend a lot of work in migrating those features, it's definitely worth considering to just dropping them, or maybe hiding them away and make them like not have a very sophisticated UI for them, because there might be really corner cases. And talking about UI, that's the third thing that you should do, from my point of view, or that I recommend to do, is redesign your user experience. If you look at modern tools, and VS Code has really done a great job in leading the way to a new user experience for developer tools. For example, modern tools often have a very reduced UI in terms of buttons that you can click or wizards that you can open. They prefer enabling the keyboard, so you can type in commands rather than clicking them. You can use the command line interface or a terminal for several commands, and developers really like that. I mean, depending on your user group, you might not deal with developers. Then like a textual interface might not be the best for you. But if your tool targets developers, it's really trendy at the moment to really provide a textual interface rather than a super full-blown UI where you can click everything, because it might be more efficient to just write it. And a good example for that is Git. If you look at the Git support in VS Code and Theia, it's really very reduced, mainly on creating commits. But all the special operations like, I don't know, branch, merge, squash, and so on, developers really like to just use a terminal for that, and they know the commands on the terminal. So there's no need to support all the use cases in the UI for certain user groups. And that will, again, potentially reduce the effort for your new UI a lot. All right. When you're done or in parallel to your conceptual assessment of your Eclipse tool or plugin, do some technical assessment. And the background for this is essentially, if you look at your existing desktop tool based on Eclipse, It typically also has some UI part and some headless part. Now, depending on the existing architecture, they might be already split into different bundles. Maybe they're intertwined a little bit. But the basic scheme is everything that is related to UI, like everything that is implemented in SWT phase or whatever, you will need to re-implement if you go for a native web-based tool. So there's no really good way to migrate manually written UI. If you use some declarative approaches or some generated approaches, like something like email forms or so, and there are options, but if you manually implemented your UI in Eclipse, you will need to re-implement that. For the business logic, and that's the headless part of your desktop application, you might potentially reuse code here, and this will typically go then to the server part of your web-based tool. And it really depends on what business logic you have there. If it's heavily intertwined with the UI, it might be better to rewrite it. But there are some examples where you can actually save a lot of effort when you reuse certain parts of your tool. Now, let's look at 3 typical examples of potential reuse. Let's assume your existing tool has a code generator. Code generators are often a lot of work. They might be even certified, developed over 20 years, might be the core value of your tool. That's definitely something you can reuse. And it's typically very easy to integrate that on the server. So you just need to add a new UI, maybe a button or right-click menu or a command that the user can type to trigger the code generation. And then maybe the UI also shows some result or so. But starting the process of a code generation is typically very simple to integrate on the backend. Could be a dedicated process that you start, or you might even provide a command line interface for your code generator. And by encapsulating it this way, you can very easily migrate it to the backend part of your web-based tool. And it's often worth to do that for things like code generator. Another example would be a custom DSL, for example, created with Xtext. For web-based tool, if you do anything with language support, you typically want to use the so-called language server protocol. Or more precisely, you want to provide a language server. That is actually an encapsulation or standard format how to provide the business logic for language support. I will not go into detail about that today. You might have heard about this. The good news is if you, for example, use Xtext, you can actually generate language servers based on the Xtext grammar. So you might reuse your grammar definition here. What you will lose is any UI customizations you have done based on your Xtext DSL. And the third example, a diagram editor, which is then, again, a little bit tricky because UI technologies are basically not available in web, like a GF or GMF. There's no button that you can press to migrate that. However, there is a replacement. For example, Eclipse GLSP, which stands for the Graphical Language Server Platform. It has a very similar concept to the language server protocol for textual languages. Eclipse GLSP is a framework to support web-based diagram editors. And what it actually enables is it provides a strong encapsulation between the rendering part on the UI or in the UI and the backend part, which contains the business logic, which is a good idea anyway in a web-based tool, but it also enables you to potentially reuse some business logic of your existing diagram editor, for example, validation rules, the underlying data model, any transformation that you do on the diagram, and so on, because you can do those things on the server, and you can, for example, also do them in Java or in TypeScript as you prefer. So there is even some potential for reuse here. Now, next step, when you thought about those technical considerations, and especially about the potential reuse case, what you actually do is you prepare the architecture of your Eclipse plugin. And if we compare this with the previous example, the idea is to extract whatever you potentially want to reuse, or not potentially, whatever you want to reuse in your web-based tool, extract that in your existing desktop tool, and encapsulate it in a way that you can actually reuse it in the web context. Again, good example, the code generator, encapsulate it in a way that you can just start it, for example, on the command line, which is a very easy way to integrate it in a web-based tool. Depending on your project, you might want to do this in parallel to the ongoing desktop development, because if you still deliver the desktop-based tool to your clients, you might want to publish new versions of the desktop tool. And if this is your scenario, you can actually refactor the UI of the desktop tool in parallel of maintaining it, and thereby enabling the headless components to be reused in the web-based version of it that you need to build up in parallel. Some hints on the technology selection. So this is definitely not complete, but the typical candidates of technologies that you might be looking for when you switch to a web-based version, especially compared to the desktop technologies that you might already use in your existing tool. So on the left side, we see the technologies that you typically use in the Eclipse desktop version. On the right side, depending on whether you go for Eclipse Theia or VS Code, the replacements. So on the left side, the Eclipse platform is replaced by Theia and VS Code, no surprise here. The Workbench API, so to interact with menus, views, editors, and so on, that's depending on which programming model you follow. That's either the VS Code API or Theia contribution points. In Theia, you could use both, because Theia also provides the VS Code API. For SWT and JFace, that's replaced with HTML, JavaScript, and any UI library you want, basically, at least for Theia. Very often React is used. It's kind of the standard choice at the moment. Language support, use language server protocol, TextMates grammars. For debugging support, you use the debug adapter protocol, and there are additional API and contribution points provided by VS Code and Theia. Xtext you can continue to use. There's an interesting project currently developed by Typefox called Langium. That's a TypeScript-based language framework, which might be an alternative to Xtext soon. So you might want to have a look at that. For diagrams, GMF, GEF, have a look at the Eclipse Graphical Server Platform, GLSP. For diagrams that are strongly coupled with textual DSL, another alternative is Proti. This is the technology that GLSP is also based on. The EMF ecosystem, including EMF Compare, EMF Validation, and the core framework eCore. There is a web project that aims to make parts of EMF reusable in a web-based context, and it provides additional components that are missing in a web-based context. So if you have an EMF-based tool, make sure to check out EMF Cloud. It's basically meant for the purpose to enable the benefits of EMF in a web-based tool. And for form-based UIs, or for example, if you use EMF forms, check out JSON forms, which is a very similar approach, but for web-based applications and tools. If you want to see those technologies in action, there is an openly available example called the Coffee Editor. This is actually a tool provided by EMF Cloud. It's fully open source. There's even an online demo. So if you go to emf.cloud, you will find the link to the Coffee Editor. You can try it. So you can start it online and basically use it for 30 minutes. And what might be even more important, you can check out the code and actually see how it's built. And it combines actually all the technologies I had on the slide before. And if you're interested in how a certain feature could be built in your own tool, you might want to use this as a template. And that's actually its purpose. It's a demonstrator on how to implement certain features in the web and how to integrate them with each other. And as you can see, it has a custom DSL, it has a diagram editor, a form-based UI, some custom code generator, analysis features, and so on. So it's pretty extensive. And I think the final technical question for the day is what extension mechanism actually to use. Now, we've talked about the comparison between VS Code and Theia, and I mentioned that there are different extension mechanisms. The VS Code extension and something special for Theia. Now, if you start a project based on Theia, you actually need to decide which of those two extension mechanisms to use. And to make this decision, let's provide a little bit more details about those two mechanisms. Now, VS Code provides a native extension mechanism that is based on so-called VS Code extensions. And the way how this works is VS Code provides an API, and you can actually write an extension that uses this API to add things to VS Code, for example, a new menu item and so on. Those VS Code extensions run in a dedicated process, so they are well isolated to not harm the stability of VS Code, and they are restricted to this specific API. Now, Theia provides a fundamentally different extension mechanism that is called Theia extension. A Theia extension is not something that lives outside of your product and only works against a specific API. Theia itself is actually composed of Theia extensions. So there's no difference between your Theia extensions and the core Theia extensions. They all are, they live together and they can all do the same things. And as a consequence, from a Theia extensions, you can actually access everything that you can access in Theia. And this is the main enabler for this great flexibility and adaptability in Theia, because from within the Theia extension, you can actually adapt almost everything without forking. And now, what makes the world very powerful, but it forces you to decide, is that Theia also supports VS Code extensions. That means in Theia, you can actually do both. You can use VS Code extensions or Theia extensions to add new features. In VS Code, you can only use VS Code extensions. Now, which of the two mechanisms should you use? The general rule of thumb is VS Code extensions are simpler for beginners because you have the restricted API that is very well documented, very stable. There's a lot of documentation out there from the VS Code ecosystem. So if you just want to do simple things like adding menus or commands and so on, you probably want to go with the VS Code extension. And it's worth mentioning that you can install VS Code extensions at runtime. So it's the classical, I add something to an existing tool model. However, there are limits to VS Code extension because the API just doesn't support all use cases. Like, for example, if you want to remove some menus or like add a toolbar or do something custom that is not supported, you cannot do. And then you need and can use Theia extensions. Now, you could think, okay, let's always use VS Code extensions until we hit the wall where we cannot do something and then switch over to Theia extensions, because that would be maximal compatibility. And we always use the perfect solution. There's a gray area in between, and that is when you want to add custom UI, like, for example, a custom editor or a custom view. You can do this with both. VS Code supports web views. In Theia, you can actually really integrate something in the DOM. Now, it's definitely more convenient to add custom UI with Theia extension, and it will be less effort. And you can definitely integrate a Theia extension or a UI that is provided by a Theia extension much better into the workbench. Like, for example, if you have an editor and you want to show problems in the problem view, and then if you double click on a problem view, jump to the right place in the editor, very difficult, if not even impossible with VS Code, very simple with Theia. So if you provide custom UI, you really have to decide whether you want to spend the additional effort of doing it as a VS Code extension. It's definitely simpler to do it as a Theia extension. All right. And last but not least, so after all those technical questions, you also need to define a strategy for your migration project. Now, I will keep this short, but some very important hints. Definitely evaluate technology choices. So web-based tools are the new normal now. So you're not an early adopter anymore. But on the other hand, many of those technologies are not very old. Like, they're pretty new. They only exist for 1 or 2 years. And it's not like when you joined Eclipse desktop, like, I don't know, 5 years ago, Many of the technologies have been there for 15 years, and they're like proven with all use cases that have adopted the technology before. That might not be the case in the web world. So definitely spend some time evaluating the technologies, whether they fit your needs, whether you need to adapt them, start to contribute, and basically find the best technology choice for your project. This can be best done by building POCs, meaning small versions of some tool features where you actually try out whether technologies fulfill the requirements, and also it enables your team to build up some knowledge. Define minimal viable products, so try to achieve something very small first and a web-based version, and not migrate everything at once. That will definitely, or most definitely, fail. Really try to define the most minimal thing that is already viable to your customers and go for that first, because again, this will enable you to learn. Potentially, many of your existing tool developers have to learn the new stack, like web technology and so on. So go slow and definitely go in iterations. What happened to my slides? Yeah, go in iterations, like smaller iterations where you add features step by step. And ideally, already deploy that to your users so you have the full learning from A to Z. And if possible, reuse something from your existing tool, as I outlined in this talk today. Last but not least, I want to mention you're not alone. There are many people adopting web-based tool at the moment, and quite a few of them are organized in a working group that's called the Eclipse Cloud Developer Working Group. This is a great place to collaborate on driving the ecosystem, learning from each other, work on joint initiatives. So if you're interested there, go to the website that is linked here. It's ecdtools.eclipse.org. And you can even join there as a guest, for example, to learn more about this group of vendors and service providers. All right, and with that, I would like to open it up for questions. And I'm pretty sure that you still have a lot of questions about your own custom project, but feel free to ask any questions that you can in the chat, and I will try to answer them. Oh, there are.
Great. Thank you for that excellent presentation today, Jonas. This is just a reminder, if anyone has any questions, just feel free to pop them in the tab at the bottom now while I do the closing. So just a reminder, we are booking Cloud Tool Time webinars into 2022. So if you're interested in presenting a talk, please feel free to fill out this form here. And now let's see if we have any questions. I think we have 2 questions here. So the first question is from Brian. When will the Eclipse desktop version be deprecated?
Yeah, that's a crucial question. Like how much time do you have to migrate? There's definitely not an end date, and it's still very actively maintained. So I don't expect it to go away for, I don't know, 5 or at least 5, maybe 10 years, because there are so many existing projects still on the technology. And it will probably still be available for even longer, but then the group of adopters will get smaller, and then the maintenance will decrease. So I think there's no need to rush anything, but if you really plan to provide something for the next 5 or 10 years, and that's often the case for tools, I would start to define a migration strategy now, essentially. And there's a second question. Should I read it myself?
Yes. You can read it or I can read it. So one other question is on emf.cloud. Is it possible to easily import existing EMF eCore/eXcore model definitions to emf.cloud?
Yes, it is. And that's actually one of the main purposes of EMF Cloud. So you can reuse the existing model definitions for sure. One component that the EMF Cloud project provides is called a model server, and that actually allows to use a model instance in a web-based tool. So it basically abstracts concepts like resources, editing domain, and so on. So it allows you to talk to an EMF model from a web-based client. And this server can be based on an existing EMF model. So definitely, yes.
Okay, great. And then I think I have 2 other questions for you. Is Eclipse Theia the only option to migrate to?
No. So as highlighted in the presentation today, VS Code is definitely another option, and that really depends. Like if you just provide a small plugin, like a feature that developers want to install into their existing IDE, I would rather go for a VS Code extension, because then you reach a huge market of existing users of VS Code. If you really provide a full tool where you have the requirement to customize the platform and basically essentially provide a custom tool, then probably, or in many cases, Theia is the better option, because it actually is built for this use case.
Okay, great. I don't think anyone else has any other questions in the audience. So if that's everything, I'd just like to thank you again, Jonas, for this excellent presentation, and thank you to everyone who attended. I hope you all have a great rest of your day.
Thanks, everyone, and have a nice evening or day. Bye-bye.